Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 7.3, which is going to deal with triangle inequalities. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use the triangle inequality theorem to determine if side lengths form a triangle, find a range of values for a side length, and order side lengths or angle measures by their size. So there's a lot in this learning goal, and throughout the lesson we're going to unpack all of those different parts. Now, before we jump into today's lesson, one thing I want to make you aware of is that section 7.3 is the final section of module 7, meaning that you guys have a quiz upcoming. So something I just want to make you aware of and let you know. Alright, so with that said, let's go ahead and get into our first idea for today, which is going to be using the triangle inequality theorem. Now, the triangle inequality theorem states the sum of any two side lengths of a triangle is greater than the third side length. So for today, we're going to deal with side lengths and determining if they form a triangle. What the triangle inequality theorem states is that the sum of any two side lengths has to be greater than the third. So if I take AB plus BC, the measure of these two added together should be greater than AC. And BC plus AC should be greater than AB, or AC plus AB should be greater than BC. Sum of two measures should be greater than the third side length. And that's what we're going to use for example 1. Now, example 1 is going to ask us to go through and determine if the given lengths form a triangle. So example 1 says, use the triangle inequality theorem to tell whether a triangle can have sides with the given lengths. So that's going to be our focus for example 1. Each problem, they're going to give you 3 different measures of potential side lengths. They want you to figure out if these 3 measures can form a triangle. So we're going to use the triangle inequality theorem, which states the sum of any two lengths should be greater than the third side length. So we're going to go through and take 2 side lengths and determine if it is greater than the third side length. So we're going to do 4 plus 8 and determine if it's greater than 10. And we need to go through and actually set up 3 inequalities to determine if in every case this works. So we're going to do 4 plus 8, let's see if it's greater than 10. Let's do 8 plus 10 to see if it's greater than 4. And then 4 plus 10 to see if that's greater than 8. So we're going to go through and position the numbers all in different spots, and then see if we get a true statement for all 3 inequalities. If I can say that all 3 of these inequalities are true statements, then you can say yes, you have a triangle. So what we're going to do is take our calculator, and we're just going to use it to guide our simple addition. So if we do 4 plus 8, we get 12, and 12 is greater than 10. So my first statement is true. Continuing on, if I do 8 plus 10, we get 18, and 18 is greater than 4. So I have two true statements. I now just have to go through and check for my last one. So if we do 4 plus 10, we get 14, and 14 is greater than 8. That means I have all 3 statements are true statements, which then tells me that yes, these 3 side lengths would form a triangle. And that is how you're going to go through and do example 1. So if they ever give you 3 side lengths and they want you to determine if they would form a triangle, you're going to go through and add 2 of the side lengths and determine if it's greater than the third. Now, before we kind of jump into the other parts, B, C, and D, I do want to kind of make you aware of a quick shortcut instead of having to go through and do this 3 times. Now, this is all well and good and really doesn't take too much time, but there is a way to do this a bit quicker to determine if side lengths form a triangle. Now, if we look at this, if I were to take one of the smaller numbers and always add it with the larger numbers, so whether it's 8 plus 10 or 4 plus 10, okay, so that's these two right here. 10 is already greater than 4, and 10 is already greater than 8. So reason would state that every time that you take the largest number and add it with one of the smaller numbers, as long as this number is greater than the other number, it will always be greater than, and thus giving you a true statement. So every time you run the triangle inequality theorem, you will always get 2 true statements. The part that determines if it is a triangle or not is when you take the 2 smallest numbers and add them together to see if they're greater than the third. So what I'm trying to say with this is instead of going through and setting up 3 inequalities, all you need to do is take the 2 smallest numbers in a sequence. So if we have 7, 9, and 18, if we take our 2 smallest numbers of 7 and 9, if I add those 2 together, so if we do 7 plus 9 to see if it's greater than 18, that will tell me if I have a triangle. So if we do 7 plus 9, we get 16. Is 16 greater than 18? It is not. Okay, 16 is less than 18, so that means no, these 3 side lengths would not form a triangle. So instead of going through and setting up an inequality 3 different times, all we need to do is take the 2 smaller numbers in the 3 side lengths and determine if it's greater than the third. So for C, that would look like taking 12 and 4. So if we do 12 plus 4, we want to know if that is greater than 16. So if we do 12 plus 4, we get 16. So is 16 greater than 16? No, it is not, because they are equal to each other. Therefore, these 3 side lengths would not form a triangle. So as you can see, we can run through this a lot quicker by just taking the 2 smaller side lengths to determine if it's greater than the third, instead of going through and doing it 3 times. If you prefer this and this makes sense to you and you want to do it this way, by all means you can do it 3 times, but you really only need to do it once, and that's by taking the smaller 2 numbers, in this case 24 and 8, adding them together, so 24 plus 8, to see if it's greater than 30. And 24 plus 8 is 32. And 32 is greater than 30. So that means yes, these 3 form a triangle. And that is how you go through and do example 1. So anytime they ask you if the given side lengths form a triangle, you can run through and do the inequality 3 times, or you can just take the 2 smaller numbers, add them together to see if it's greater than the third. And that will tell you whether or not it forms a triangle. All right, so that is example 1 for section 7.3. Example 2, we're going to use the idea of the triangle inequality theorem to help us define the range of values for a given side length. So if we look at example 2, it asks us to find the range of values for x using the triangle inequality theorem. So for each of these problems, what they're going to do is have one of the side lengths defined as x, and we need to go through and determine what possible measures x can be that would allow this to be a triangle. So each problem is going to give you x, and then it's going to give you two of the side lengths defined, in this case 12 and 10. And we're going to use that 12 and 10 to determine what potential values x could be. Now, because we're dealing with a range, we're not going to get an exact one number, but we're going to have a range of potential numbers. Now, we're going to use the triangle inequality theorem in essence, but we're not going to use it in terms of going through step by step to solve this. What we're going to do is take the two numbers for the other two side lengths, 12 and 10, and we're going to do two simple things with those two numbers. We're going to subtract them, and then we're going to add them together. So if we take 12 and 10, we're first going to do 12 minus 10, and then we're going to do 12 plus 10. So if we do 12 minus 10, we get 2, and if we do 12 plus 10, we get 22. So I've done my simple operations, and I get 2 and 22 as my two numbers. So for my range of values for x, it would be 2 is less than x, which is less than 22. And that is my answer for part A. So example 2A, I just took 12 and 10, subtracted them, and then added them. And then we have 2 is less than x, which is less than 22. Know that whenever you have this set up, it's always going to be less than x, less than. So you just have to figure out what the numbers are at the front and at the back of this range. Smallest number goes first, largest number goes second. Alright, so if we continue on with that, so for B, again we have x for our missing side length, and then they tell me this side is 15, and this side is also 15. Knowing that, we're going to take 15 and 15. We're going to do 15 minus 15, and 15 plus 15. So if we do 15 minus 15, we get 0. And if we do 15 plus 15, we end up with 30. So 15 minus 15 gives us the 0. 15 plus 15 gives us our 30. So my range of possible values for x would be 0 is less than x, which is less than 30. And that is my answer for part B. So whenever they want you to go through and find a range of values for x, when they're trying to ask you to figure out a missing side length, take the two numbers of the two side lengths you know, subtract them, and then add them, and that is going to give you your range of values. Alright, now part C and D is just going to be the same thing as we did for A and B, and because these ones are pretty straightforward, I'm going to leave parts C and D for you to do on your own. They are done on my completed notes, so if you would like to see an example of how to do C and D, or if you want to check to see if you're right, just open my completed notes to see if you are on the right track. Alright, next, for example 3, they're going to ask us to go through and order things from least to greatest. Now, specifically for example 3, it states for each triangle, order its angle measures from least to greatest. Now, if you look at our stuff for example 3, for triangle ABC, they don't tell me anything about the angle measures of A, B, or C. All they do is tell me the side lengths of the triangle. So for example 3, we are going to order the angle measures from least to greatest when all we know is the measure of the side lengths. Now, this side angle relationships in triangles is going to give us guidance on that, and that states that if two sides of a triangle are not congruent, then the larger angle is opposite the larger or longer side. What this means is if I know AC is the longest side, so let's say I know it's the largest side, that means the angle that is the largest is the angle that is opposite. So what we're going to use to do least to greatest is we're going to find the smallest side length, and then the angle that's opposite of that side length is going to be our smallest angle. Our largest side length, the angle opposite, is our largest angle. So if we use that concept for example 3, we're going from least to greatest for example 3. So if we look at example 3a, we have triangle ABC with the side lengths 21, 20, and 22. To figure out least to greatest, we need to start with the smallest angle, so we need to look at the smallest side. So between 21, 20, and 22, which of these three is my smallest side length? It's going to be AB because it's 20. So 20 is my smallest side length, or AB. So to find the smallest angle, we're going to go to the angle that's opposite of that side, in this case, C. So the angle that's opposite of AB is C, and that's going to be my smallest angle. Now to find the next angle in the sequence, we're going to go to our next smallest side length. So between 21 and 22, which of these two is my smallest side length? Is it 21 or 22? 21 is smaller than 22, so that's going to be my next side length to use. And the angle that's opposite of 21, or AC, is angle B. And then because we're talking about triangles, I've already talked about three angles, C and B. So my remaining angle is A. So that means angle A is my largest angle, which matches because the side opposite of it is our largest side. So from least to greatest, it's angles C, B, and A. So when you go through and you're asked to order angle measures from least to greatest, or greatest to least, doesn't matter which one they want you to do, okay, you're going to go through and either find the smallest side length or the largest side length, depending on the situation. And you go to the angle that's opposite of that side length, and that is going to tell you which angle is the smallest or the largest. Alright, for part B, it's going to be the same idea. So we have to determine, again, least to greatest. So between 15, 10, and 12, which of these three is my smallest side length measure? Between 15, 10, and 12, it's 10. So it's the side AB. And the angle that's opposite of that side is angle C. So it means angle C, again, is my smallest angle. To figure out my next one, we have to figure out what my next smallest side length is. So between 15 and 12, which of these two is my smallest side length? In this case, it's going to be 12. And the angle that's opposite of 12 is going to be angle A. So that means my second angle is A. And because I've already used C and A, that leaves angle B as my largest angle. And that is how you're going to go through an order from least to greatest for the angle measures when you only know the side lengths. Now, parts C and D are just going to continue much of the same idea. If we look at example C real quick. For example C, again, least to greatest, so between 15, 32, and 40, which of these three is my smallest side length? And in this case, it's 15, so BC. And the angle that's opposite of that is angle A. So that means angle A is my smallest angle. Next, if we look between my last two, so 40 and 32, 32 is smaller than 40. So that means this is my next smallest side length. So the angle opposite would be angle B. So angle B is going to be my second one in my sequence. And because I've already used A and B, that means angle C is my largest angle. And that is our answer for C. Now, part D is just going to run through the same idea, so I'm not going to run through that as I've already done 3 examples. Per usual, it is done in my completed notes, so you can use that as a reference if you want to practice D on your own to see if you are correct and if you are on the right track. All right. Lastly, for example 4, they are going to ask us to go through and for each triangle, order its side lengths from least to greatest. So we're going to do the reverse process of example 3, where they gave us the side lengths and we had to order the angle measures. For example 4, they're going to give us the angle measures and we have to find the side lengths from least to greatest. Now, we're going to continue the same idea that we did with example 3. It's just instead of starting with a side length and going to an angle, we're going to start with an angle and go to a side. And that's all that this part is really going to say in the angle-side relationship. It's the same thing as the side-angle relationship, that the longer side is opposite the longer angle, or the smaller side is opposite the smaller angle. So, for example 4, again, we are doing least to greatest, so we're doing smaller to bigger. So if we look at example 4a, for triangle ABC, we've been given the angle measures of 30, 100, and 50. So between 30, 100, and 50, which of those three is my smallest angle? Angle A at 30 degrees is my smallest angle. So we have to go to the side opposite, which in this case is BC. So that means BC is going to be my smallest side length in this triangle. All right, next we're going to go through and continue the pattern. So between 50 and 100, which of these two is smaller? 50 is my next smallest angle measure. So the side opposite of angle C at 50 degrees is going to be my side length of AB. So that means AB is my next side length in the sequence, leaving me with my third side length of AC. And that is my answer for example 4a. So if you were asked to go through and order the side lengths from least to greatest, find the smallest angle, the side opposite that angle is our smallest side, and you just continue that to find your sequence. All right, so if we went through and continued practicing this idea, if we look at B, for B, we have the angle measures of 45, 70, and 65. So between these three, which of these three is my smallest measure? In this case, it's 45. So the side length opposite of 45, angle C, is the side AB. So AB is going to be my smallest side length. Then between 70 and 65, which of these two is my smaller angle? In this case, it's angle B at 65 degrees. So the side opposite angle B is going to be the side AC. So it goes AB, AC, and then I only have one side left, which is going to be BC. And that is my order from least to greatest for the side lengths. All right, so parts C and D are just going to run through the same idea as A and B. I'm going to leave those ones for you to do and practice on your own. And like I've mentioned throughout these notes, it is done in my completed notes, so pull those up if you want to look to see how they're done, or if you are on the right track, if you go through and practice them on your own. I suggest you run through these by yourself real quick to see if you understand the concept well, and if you get the right answer. All right, so that is it for our notes on section 7.3 on the triangle inequalities. And I appreciate you guys taking the time to listen. And if you have any questions, be sure to let me know the next time you see me or shoot me an email. Otherwise, that is it for today. And I hope you guys have a great day. All right.